Hello students, welcome back. I hope you have a good break. Today we're going to do a quick revisions on what we've learned so far. In the chapter of trigonometry, we have learned how to solve trigonometrical equations involving Pythagorean identities, the addition formulae, and the double angle formulae. So after this quick revisions, we'll be going on to learn the R formula. Right, so let's look at what we have learned so far. Right, we start off by learning all about the trigonometry functions such that you can actually express tangent theta as sine theta over cos theta. Cotangent theta will be equals to cos theta over sine theta. Secant theta is equals to 1 over cos theta. Cosecant theta is equals to 1 over sine theta. And we also have learned the Pythagorean identities, right? Such that sine squared theta plus cos squared theta equals to 1. 1 plus tangent squared theta equals to secant squared theta. 1 plus cotangent squared theta equals to cosecant squared theta. After that, we moved on to the addition formulae for cosine, following the addition formulae for sine, and then for tangent, after which we learned the double angle formulae. Right, so these are the concepts we've learned so far. So we'll be solving some problems that involve this concept. Right, so my advice to you folks is that if you want to solve the trigo problems involving these concepts well, it's very, very important that you make friends with all these formulas. Making friends as in knowing them well, like know the formulas well, without even having to refer to the formula sheet. For example, you are able to recall that the addition formulae for sine, supposing sine bracket a plus b, you're able to recall that it's sine a cos b plus cos a sine b without having to refer to the formula sheet. And if you can master this skill, it will be very useful in helping you to solve any trigo problems. Right, I've classified the questions into different categories: basic, intermediate, and advanced. So let's look at the first basic questions. Right, so you are given a quadratic equations in terms of the cosine function, and we're asked to solve it. Right, and the answers we're solving for the angle x, and this angle x has to be between 0 and 360 degrees inclusive. All right, I'm going to present to you two different ways of solving it. But first of all, let's do a recap on what does cosine square x means. So cosine square x means cosine x multiplied with another cosine x. All right, so the first method is to rewrite the equations into something that you are familiar with. So that is to let cosine x to be represented by a letter a. And in this case here, you will have 2a squared minus 5a minus 3 equals to 0, which is something that you're familiar with. It's and quadratic equations. And with that, you'll be able to factorize it into two linear factors. So a can be equals to negative half or a equals to 3. And then you can just replace the a with cosine x. That is the initial value representing a. Right, so this is the first method. If you're not confident enough in solving trigo equations, so make it into something that you are familiar with. Of course, the second way is that you recognize that what you're getting is just a quadratic equations where you can just factorize it directly. Right. and then you apply the zero product rule, and you'll still get the same answer, which is cos x equals to negative half or cos x equals to 3. So the next step will involve solving it. All right. So let's look at how we can find the value for cos x equals to negative half first. So to do that, we're going to use the concepts of ASTC to solve it. So ASTC will require you to find the reference angle. And finding reference angle, you have to be reminded that the reference angle is and the cube angle, which is between 0 and 90 degrees. So therefore, when you trigo inverse any value to find the reference angle, it has to be positive. Right, so let's look at cos x equals to negative half. So for cosine x equals to negative half, the angle x will come from the second or the third quadrants. Okay, and then the reference angle will just be cosine inverse half. Yes, so cosine x equals to 3 will not be applicable if you were to remember that we have learned the shapes for y equals to cos x, the maximum value for y will be 1, and the minimum value for y will be negative 1. So cos x equals to 3 will be out of the range. That's why it's not applicable. Right, so let's get back to cos x equals to negative half. So the reference angle will be just be cosine inverse half, which is 60 degrees. And since the answer x will have to come from the second quadrant, it would have to be 180 minus 60. Right, and then for the third quadrant, it will have to be 180 plus 60. Right, so this is how you solved these basic questions. Right, let's look at the next questions. In these questions here, you would observe that there are two trigo functions there. One is sine square x, the other one is cos x. And we know that we can't solve a trigo equations where you have two different trigo functions. Right, so in this case here, we have to, the concepts involved here, yes, is we have to express sine square x in terms of cos square x. All right, so I have put the word y there for you to think about it. Why is it that I need to express sine square x in terms of cos square x? So to do that, I will need to use the concepts of Pythagorean identities. So which one do I use? Yes, of course, I would have to use sine squared theta plus cos squared theta equals to 1. So from there, I can make sine squared theta the subject, which will give me 1 minus cos squared theta. And I can substitute my sine squared x this one here, with 1 minus cos squared x. And then I'll end up getting a quadratic equations involving cosine, which is something similar to what we have done in part A. Right, where what I've done here is I actually divide by -2 throughout. So -6 divided by, that means I'm dividing it, this whole chunk of thing, with -2, so that the -6 divided by -2 will give me 3. 2 divided by -2 will be -1. 4 divided by -2 will be -2. Right, but if you find this confusing, then another way of doing it would be you just multiply every term with -1 throughout to get 6 cosine square x minus 2 cos x minus 2 equals to 0. Right. Sorry, that is 4. And then you just factorize 2 out. Factorize 2 out to get 2 bracket 3 cos squared x minus cos x minus 2 equals to 0, which is what I have shown on the screen. Okay. All right. And with that, you can just factorize it. Okay. I'm not. By now, you should be proficient in doing factorizations using the cross method or whatever methods to get the 2 linear factors. And then you will get cos x equals to negative 2/3 or cos x equals to 1. So based on your ASTC again, the cosine, the angle will have to come from the second or the third quadrants, right? Right, so that's my reference angle. So reference angle will be cosine inverse positive 2/3. Okay, remember your reference angle is a basic angle that's between 0 and 90, so you have to triple inverse a positive value. All right, so we're expressing your answers in terms of degree, so put it to 2 decimal places first. So for the second quadrant will be 180 minus alpha, and then the third quadrant will be 180 plus alpha. For the final answer, you have to express it to 1 decimal place. That's for final answer, 1 decimal place. All right, so before that, it's in between answer is the 2 decimal places for better accuracy. Okay, what happened to the other value where your cos x equals to 1? So when you have cos x equals to 1, I will need you to bring you back to your cosine curve. Okay, so to get cos x equals to 1, that is when the angle x is 0 degrees or 360 degrees. Okay, so for these questions, you have 4 answers. Okay, 0 degrees for the 8.19, sorry, 0 degrees, 131.8 degrees, 228.2, and 360 degrees. All right, let's look at the next questions, which is slightly harder than the one we have done earlier. Right, it's harder because you were involved addition formulae for sine. How do you know that you need to use addition formulae for sine? So that is the reason why in the earlier slide, I've actually advised you folks to familiarize yourself with all the formulas. So if you have familiarized yourself with all the formulas, you will realize that this value here will require you to apply the addition formulae for sine. And for some of you who are not familiarized with the formulas, you may be making this kind of mistake. What is the kind of mistakes that you may make? Yes, you may think that sine bracket x minus 5 pi over 6 is sine x minus sine 5 pi over 6. And that is not correct. Okay, so the correct one is that will give you sine x cos 5 pi over 6 minus cos x sine pi over 6. And I usually like to convert the angle in radian to degree. I'm more comfortable managing angle in degree. So 5 pi over 6 is 150 degrees. So for cosine 150 degrees, if you were to convert it, rewrite it as a reference angle, so it's equals to negative 50. Why negative 50? Because 150 degrees actually end up in the second quadrant, and cosine of an angle in the second quadrant is a negative. So therefore, your cosine 150 is negative cosine 30. Negative cosine 30. And cosine 30, it's a special angle. Okay, if I've already forgotten your special angle, please revise. So cosine 30 is square root 3 over 2. So it's negative square root 3 over 2. And of course, sine 150 is equals to sine 30. And since sine obtuse angle is a positive value, so it's equals to sine 150 is equals to sine 30, which is equals to half. All right, so the next thing is I'm just going to multiply by cos x on both sides. Right, and then group all your cos x together. We need to group all your cos x together before we can actually apply the one highlighted in green. Okay, so the next step now is I'm going to divide both sides. Okay, the reason to do that is so that I will be able, okay, to write the equations in terms of tangent x. Okay, and under your ASTC, the angle will come from the second or the fourth quadrants if you have a negative value for tangent x. Alright, so the next step is to find a reference angle, which is tangent inverse positive 5 over 2 square root 3. So that will give you 0.9649. Alright, if you look at the questions, you're supposed to leave your answer in terms of the radian. So remember to convert the mode in your calculator to the radian mode before we actually evaluate your tangent inverse bracket 5 over 2 square root 3. Alright, so the answer will come from the second quadrant, which is pi minus alpha. And then for the fourth quadrant, it will be 2 pi minus alpha. Okay, so this is how you solve this intermediate questions. Right, so sometimes you may ask to prove a trigo identity instead of solving it. So if you look at this intermediate 2, you ask to prove the identity, and then using the results that we have proved in part I to solve the equation. Alright, so let's look at part I. We usually proved from the side that has more things to work on. So if you were to compare what you have on the left with what you have on the right, obviously you have more things to work on from the left hand side. Yes, and in this case here, we'll be using the double angle formulae. How do you know that we'll be using the double angle formulae? Because basically, you will see that what we are having here is cosecant 2a. Right, so 2a is a double angle. Right, so with that, I've shown you the double angle formulae. Alright, let's start with the left hand side. So what do? I think when we see something like that, some of us will be very eager to open up this bracket, which I would advise you not to. Let's try to simplify things that it's obvious that it's easily simplified. So if you were to look at the denominator, right, the common factor is sine A. So let's leave the numerator alone and then factorize sine A from the denominator. And you'll see that this and this can just gives you 1. And you're left with the secant A over 4 sine A. Right, so secant A is 1 over cos A. Right, so that will gives you 1 over cos A divided by 4 sine A. And then you change your division sign to multiplication. Right, and you'll get 1 over 4 sine A cos A. And so if you are one of those that have made friends with the formula, you will know that 4 sine A cos A, it's equals to, like you can write it as 2 times 2 sine A cos A, which will be actually simplified into 1 over 2 sine 2a, because sine 2a is 2 sine a cos a. Right, but if you're not familiarized with the formula, you may be stuck here and you may not know how to continue. All right, and from there we can further break it up into two fractions. Okay, half times 1 over sine 2a. Why I want to break it up? Because I want to show you that 1 over sine 2a can be expressed as cosecant 2a, which is what we're supposed to prove on the right hand side. Okay, so that's how we do it. All right, so let's look at part 2. Okay, so to solve it, we are just equating half cosecant 2a equals to 1, right? Because this will be equals to this, so therefore half cosecant 2a will be equals to 1. All right, so that's 5 cosecant 2a, which is equals to 2, and cosecant 2a is 1 over sine 2a. All right, okay, so for sine to be positive, the answer under ASTC, you can get it from the first or the second quadrant. So we need to find the reference angle again, which is sine inverse half 30 degrees. Right, your angle will be between 0 degrees and 360 degrees. Okay, that's for A. But if you look at what we have here, we are finding 2A. So your 2A will be between 0 to 720 degrees. Right, so basically you will be getting like more answers. Let's see what happened. Right, so 2A is equals to the first and the second quadrants. Or we can go on to one more round, because the answer has to be between 0 to 720. So 30 plus one more round is 360. Right, and this one also you need to add one more round, which is 360. Okay, and finally you have 4 answers there. Finally divide by 2 to get 15 degrees, 75 degrees, 195, and 255 degrees. All right, so sometimes the questions may involve the addition formulae for cosine. Okay, so in this case here, you must be able to apply the formula correctly. Okay, so cosine bracket A plus B multiply with cosine bracket A minus B. So let's use the formula correctly first. Okay, so that if we were to observe it very carefully, you have cos A cos B minus sin A sin B, and then cos A cos B plus sin A sin B. So that will remind you of the algebraic identity we've learned. Yes, so that will give you A squared minus B squared. So from here, what you'll be getting will be cos squared A cos squared B minus sin squared A sin squared B. Alright, so it's very important that for proving or showing, we must have an idea of what we are getting at in the end. And if you look at what we're supposed to get in the end, it has just, the trigo functions, cosine functions. So that means we need to eliminate your sine. Okay, that means we need to do something to this to express it in terms of cosine. And of course, that will involve using the Pythagorean identities, where you can make your sine squared A equals to 1 minus cos squared A, and sine squared B to be 1 minus cos squared B. Okay, and this step here will involve how strong you are in your algebra. If you are the one strong enough, okay, you will see that you have to put a bracket here. Okay, if you're not strong and you forget the bracket there, you won't get the answer. Okay, right, so if you put the bracket there, you will just simplify it, and then you will see that you will get the answer that's needed. Okay, so for part B, right? We say without using a calculator, deduce the value. So usually it's making use of the part A answer. So if we were to compare your cos pi over 12, cos 5 pi over 12 with what you're given in part A, you see that A plus B is equal to pi over 12 and A minus B is equal to 5 pi over 12. And you end up having to solve them simultaneously, which I'm not going to show you the steps. You should be proficient enough now to solve simultaneous equation, and you end up getting angle A to be 1/4 pi and angle B to be negative 1/6 pi. And you can just substitute these two angles into your cos squared A plus cos squared B minus 1. And you can just easily use your calculator to evaluate it. And you will get 1/4. Okay, so when you want to evaluate this using your calculator, just be careful, change the calculator mode to radian, okay, before you evaluate it. Right, let's look at the next questions. This is the questions on proving again. So we asked to prove that cosecant 2 theta minus cotangent 2 theta equals to tangent theta. Right, so this looks like a double angle formula kind of questions. On the left hand side, the cosecant 2 theta and the cotangent 2 theta double angle. But before we apply the double angle, I think we will need to rewrite cosecant 2 theta as 1 over sine 2 theta and cotangent 2 theta as cosine 2 theta over sine 2 theta. Let's see what happened. Okay, and then we're going to combine both of them into 1 minus cos 2 theta over sine 2 theta because they have the same numerator, right? They have the same numerator. Okay, the next tricky part is that if you look at cosine 2 theta in the double angle formula, you see that there are three formulas that I can use here. It's either cos squared A minus sine squared A, or 2 cos squared A minus 1, or 1 minus 2 sine squared A. Alright, so which one to use? Yes, I would use 1 minus 2 sine squared A. Why you want to use that? You'll see why at the next step. And of course, your sine 2 theta, you can write it as 2 sine theta cos theta. Okay, look at what happened to the numerator. I use cos 2 theta. I can eliminate when you open up this bracket here, what you get is 1 minus 1 plus 2 sine squared theta. So you eliminate 1 and you make the expression simpler. So that is the reason when we solve any problem, we want to simplify things. We don't want to complicate matters. Okay, so from there you can simplify it further to become sine theta over cos theta, which is equals to tangent theta, which is what we're supposed to find at the right hand side. Okay, so A part I, it's relatively manageable. Alright, let's look at A part 2. So if you look at A part 2, yes, we're going to do some deductions. Right. So since cosecant 2 theta minus cotangent 2 theta equals to tangent theta, if you look at what happened to the angle, right? 2 theta, then become theta. Right. That means if I have 4 theta, then what happened? 4 theta here, then this will become 2 theta. So if I have cosecant 6 theta minus cotangent 6 theta, that will be equals to tangent 3 theta. Okay. Right. Yes. So I've just highlighted to you the relationship among them. So I can actually just use tangent 2 theta equals to negative square root 3. And because the theta is supposed to be between 0 and pi, and we are dealing with 2 theta, so the range will have to be between 0 and 2 pi. Okay, so for tangent to be negative, the angle will come from second and fourth quadrant. As usual, let's find the reference angle, which is tangent inverse square root 3. Okay, which is pi over 3, because your answer has to be in terms of in radian mode, between 0 and pi, that's in radian mode. Alright, so second quadrant will be pi minus alpha, and fourth quadrant will be 2 pi minus alpha. Okay, right, and from there you can just go on to find theta, which is 1/3 pi, and 5 over 6 pi. Right, let's look at the last questions, which are considered to be advanced questions because it tests you on not just knowing how to apply the formulas, it also tests you on how good you are managing algebra. Alright, so in this questions here specifically, you are asked to use the identity for tangent 2a. Right, so the formulas for tangent 2a will be 2 tangent a over 1 minus tangent square a. Right, so what we're going to do is, you are specifically asked to use this formula. Right, so I'm going to let angle A to be 75 degrees. Right, then you will end up having 2 tangent 75 degrees over 1 minus tangent squared 75 equals to tangent 2a. So if a is 75, 2a will be 150, right? Okay, so if you were to look at what you have got on the screen, you can't simplify tangent 75. You're supposed to find tangent 75. So the only thing that you can simplify will be tangent 150. Right, so tangent 150, okay, under your ASTC, right? 150 is here. So that will be, your reference angle will be 30 degrees, right? But because tangent of any angle, it's negative in the second quadrant. 150 degrees will end up in the second quadrant, right? And tangent is negative in the second quadrant, right? So therefore, that explains why there's a negative here, okay? So tangent 150 is equal to negative tangent 30. Now tangent 30 is a special angle, which is square root 3 over 3. So therefore, tangent 150 is equals to negative square root 3 over 3. So this is an advanced question because you must know how to apply the formula and you must remember your special angle. Okay, then the next thing is, why do I let tangent 75 degrees equals to x? Because if you don't, and if you're going to leave it just as 2 tangent 75 degrees over 1 minus tangent squared 75 equals to negative square root 3 over 3. You'll see that it's quite a handful to manage when you do a cross multiply and then you keep seeing tangent 75, it's quite confusing lah. But if you were to let tangent 75 equals to x, it will convert the equations into a quadratic equations that you are familiarized with. Okay, so this is what happened. So you replace your tangent 75 with x, you get 2x over 1 minus x squared equals to negative square root 3 over 3. You just do a cross multiply. Okay, and then you bring everything to the left hand side to form a quadratic equations in terms of x. And you can just factorize it. And of course here, the only way to factorize it is to use the quadratic formula. You can't factorize this using your calculator, okay, or using the cross method. Because if you look at what you're supposed to find, it's in terms of cert. So that gives you an idea that you have to use a quadratic formula. Okay, so here your a will be equals to square root 3, b is equals to negative 6, c is equals to negative square root 3. And if you remember your quadratic formula, alright, then we just substitute the values of ABC into the quadratic formula. Okay, and this is what you get, right? And this one here, you can just use your calculator to work it out to be 48. So that will be 6 plus minus square root 48 over 2 square root 3. And if you were to remember your cert, this one can be simplified into square root 16 times square root 3. Okay, and then yes, you can split it into two fractions. 6 divided by 2 square root 3 plus minus, that means you can split it into two fractions, right? This one over this to give you this, and this over this to give you this one, right? And again, you can further simplify it into 3 over square root 3 plus minus 2, and 3 over square root 3 you can rationalize it by multiplying with square root 3 over square root 3 to get just square root 3. This one should not come up yet. This will give you square root 3 plus minus 2. Okay, and because your x represent the tangent 75, right? And 75 degrees is a cube angle, right? So tangent 75 will be in the first quadrant, and tangent 75 will be positive in the first quadrant, right? So therefore so therefore you reject square root 3 minus 2. You only accept square root 3 plus 2, because square root 3 minus 2 will gives you a negative value. Okay, right. So this is how you do these advanced questions. And I have something for you to ponder on. And that is supposing, the questions do not specify a certain method. In this case, it specifically asks you to use the double angle, which is tangent to A, right? Do you think it's easier to use the addition formulae? And if you think it's easier to apply the addition formulae, then how do you think you can use the addition formulae to go about showing that tangent 75 degrees is 2 plus square root 3? Okay, so that's all, folks, for this video.